Welcome you all to this section of projection of solids. In this section, we'll be looking at a couple of tips and tricks which could be used while drawing projection of solids. And some of the tips could be like how to position and orient the views, things to remember in axis tilting problems, which view to start with, how to find hidden lines. So these are a couple of different aspects related to projection of solids, which we'll be looking at bit by bit in this section. What you see on screen is a pentagonal prism when looked from the top. So this particular prism is in a particular orientation. So we'll see how orientation of particular solid will decide how the views will be and how it will help you solve problems. Let us take the case where we need to tilt this this pyramid in such a way that we need to tilt it with respect to a corner. So in the last example, we have seen that we have tilted a square pyramid with respect to one of its base edges. But here we'll try to see how we should orient it in such a way that we could tilt it with respect to a corner. So it's quite clear that these are the base corners of this pentagonal pyramid, and this is the apex. So if I try to rotate this pyramid, now we have rotated the pyramid so that one of its corners is in this orientation. So why we have made this orientation towards the right side, or why we have made the orientation of this corner to the right side, there's one interesting fact here, that suppose I try to look at the front view now. If I try to tilt the solid, so when tilted, the front view looks like this. Now if we try to see it in 3D view, this is a corner which we are interested to tilt this solid with. So why we have actually oriented it in this fashion is that this particular orientation will help us in the next stage of tilting. It will be easier for us to make this point as a reference and tilt this whole solid the next stage of drawing views. So that's the reason why we have oriented the solid so that this corner is on the right hand side. And one more reason is that all the views we have been doing so far, the views will start from the left towards the right. If you remember the previous problem which we have done for the square pyramid with one of its base edges. In a similar manner, in the next stage, which is tilting this solid with respect to the corner, which is going to be on the right hand side, and that's the reason why we have made this corner to be point to the right, and so that in the next stage when we try to tilt this solid, this could be tilted with respect to this corner itself. So this is one of the things you have to keep in mind while doing projections of solid, how to orient or how to draw your view so that it will enable you to draw the next tiltings and the next orientations much easier. So what you see on screen are the projections of a pentagonal pyramid in 3 different orientations. That is, here in this case, one of its base edges is made perpendicular to the vertical plane, and in this case one of the corners is made to orient in such a way that you can tilt this corner in the next stage. So that is one case. Yet another case where one of the base edge is made parallel to VP. So this particular 3 examples is specifically mentioned to highlight the importance of orientation of views. So in questions you could see multiple terminologies like base edge parallel to VP, base edge perpendicular to VP, a particular face inclined to VP, face inclined to HP, and those kind of terminologies you could see. So the first and foremost thing which you need to understand while learning projections of solids is what is a base edge, what is a slanting face. For example, the slanting face for a pyramid is this one. So if the problem is about tilting the solid with the slanting face tilted, or you could even have a case where the slanting face is made perpendicular to the horizontal plane. So these kind of tricky questions might be asked. So you should be able to visualize basically how it is going to look like. So this is basically what we'll be learning in this section. So in the worked out problems, you could see different types of problems being solved for different in different ways. If you look at this pentagonal prism on screen, this prism could be explained in 2 ways. One of the ways is you could say that this prism has its base tilted at a particular angle. Let's say it is 30 degrees. This is one way of telling it, that the base of a pentagonal pyramid is tilted with some angle with respect to the horizontal plane. So that is one way. Another way is to say that one of its faces, vertical faces, is tilted with respect to the horizontal plane. So this is another way of telling it. And while mentioning the tilting, along with that, in many cases there will be additional information given with respect to the solid. For example, one of the things they could tell is that this is tilted in such a way that one of its base edges is perpendicular to VP. So this is a typical case like that. So in this particular case, the edge with respect to which it is tilting is perpendicular to VP, and its base is tilted with respect to some angle to the horizontal plane. So these all actually is a way of mentioning how the solid is oriented in 3D space. So if you understand the whole terminology of the solid, like base edge, the vertical face, the slant face, etc., you should be able to visualize how the solid is going to sit in a 3D space. So once you are able to visualize this, it is much easier for you to actually start drawing the views. So the next thing I would like to highlight is with respect to how to find hidden faces. This is a typical problem which people face. How to identify, once you draw a projection, how to find which are the hidden edges or hidden faces. For example, in this particular case, if you look at the solid from the top, it is quite clear that these 3 faces are seen, and all the other faces. Totally there are 5 plus 2, 7 faces, 5 vertical and 2 bases. So of these faces, only 3 are completely visible. The other faces are all hidden from view. So how to decide quickly? So for example, if you are trying to join, imagine these are the points which you get while drawing the projection, and you join those points and you get a visible line. I think in the last video I have mentioned that when you join the boundary points or the boundary vertices, those lines definitely will be going to be these are the bounding vertices. So if I join them, you're going to get a visible set of edges. And when it comes to the in-between edges, these points also will be seen while drawing the projections. We'll be marking these points, but the lines joining these points, these particular points, they are all hidden in technical. So let us see this pentagonal prism drawn on a sheet of paper with the views. So as we have seen in the 3D view, this prism is tilted with respect to its base, and we are trying to see how we can draw the top view of this tilted prism. So we have drawn the projectors from the different corners or vertices, and we have seen points where the corresponding points meet. That is, we have drawn projectors from the front view of the tilted solid as well as the original top view, and the corners are marked as A, B, C, D, and E for the bottom, and P, Q, R, S, T for the top. So you could see in the front view they are marked as P dash, Q dash, and A dash, B dash, etc. And that same particular front view is tilted in the second stage, and we have projected them down, and from the top view it is projected across. So wherever the similar points meet, we have marked them. For example, this line B and this B dash here, they are meeting at this point. For example, Q dash, T dash, this line. So here it will be Q, and here this point it will become T. So we can mark this as T. So now what we could do is we would like to join the boundary points. So let's try joining those points. So we'll start with A, and we'll start with A, B. So now we have joined all the boundary points, and then as we said before, the CD will be definitely be a hidden edge. Since we look from the top, it is completely hidden from view, so that we can very clearly mark it as a hidden line. And then one more thing we are sure is the top face, which is a PQRST face joining these corners, they are also definitely visible. So what we could do here is to join them. So let's start with the Q, PQRST. So P2 Q and Q2R is R2S, they are already joined, and we'll also join P and T. So now that these complete face is fully visible, and the remaining edges are all will be hidden. So to make it much more clear, let us make them as continuous thick lines. So now you could see that these are the hidden, these are the visible areas. So the other edges, for example, CR, the edge CR, and that edge will be a hidden edge. So we'll draw that edge, and we'll also join C and D as we said before, and we'll join D and S, then we'll join the E and D, and similarly B and C. So as per the theory which we told before, the technique is based on our tip. Any edge which is coming inside a face and crossing another set of edges, for example this edge is crossing this edge, so that is going to be a hidden edge. So we'll change these edges to dashed ones, to change them to dashed ones, and this also have to be converted into dashed ones. So now we have all the hidden edges marked, and we also have one more edge which we have missed out, which is between A and B, and that edge will also be a visible edge since it is in the front, and we'll make that visible edge as well. So now we have joined. So the steps are like this: we join the boundary points first of all, then look at which are the hidden edges. Since B, C, CD, ED, all these edges will be completely hidden since they are inside these visible faces. So edges which are inside visible faces always will be hidden from view. So with that tip, hopefully you would have got an idea how to locate hidden and visible edges from a view. So the next important point I would like to mention is with respect to the axis of a solid. So if you look at this particular view which we have tilted, so in this particular case the question might have been like might have come in two different ways. One of the ways is like this: there's a pentagonal pyramid which is tilted with its base at an angle of say 30 degrees with respect to the HP, and its axis tilted with respect to VP at say 45 degrees. This could be a type of question. So when you say axis, one important thing we'll have to keep in mind that this axis which we see in this is not the true length of the axis. It's a foreshortened length. If you look at the axis, this is a true axis. So this true axis when projected down will only be a foreshortened and not a true length. So if you are taking this axis at 45 degrees to the XY line, that will not be the exact answer to this problem. Instead, if the question had been like the top view of the axis is inclined to the XY line at 45 degrees, orienting this solid like this should work, or orienting that is right. But instead, if you are asked that the axis is tilted at 45 degrees to the vertical plane, it means that the true length of the axis should be tilted. So the method to do here is we will be actually starting from some point. We'll draw the axis. We know anyway the axis, total true length axis, is already known in the question. So the method is we'll be drawing the axis in true length in whatever given orientation you want. We'll be drawing that in the true length with the required angle, and then using the projection of lines technique, what we'll do is we'll draw a locus of this point. So we are assuming that this is a point with respect to which the axis is getting tilted. So at this angle we'll mark with respect to the XY line as in our case it could be 45 degrees. And once we know this line and once we have got this locus through which the other end of the axis is passing through. Now with that locus and this foreshortened length as radius, so what we could do now is we with this point as center and this radius, we can draw another line here. So that would be our actual top view with respect to this tilted true axis. So this is something which you will have to keep in mind while doing such problems. So more on this will be explained in one of our worked out problems where the true axis is being inclined to the vertical plane. So with this we are ending this particular section.